Hello students, today we are going to see an interesting important questions from solution chapter in that one among Azeotropes mixture. You know what are the questions can be asked from Azeotropes mixture? What do you mean by Azeotropes mixture? How can we identify it as Azeotropes mixture? And types of Azeotropes mixture, examples of Azeotropes mixture. These are the questions you can expect. First and foremost, we will go and understand and analyze what do you mean by Azeotropes mixture. Azeotropes mixture is nothing. It's the same concentration of vapor phase and fluid phase at constant temperature. Vapor phase, it's a gaseous state. Liquid, that means a fluid phase, it's a liquid state. Both are having a same concentration at constant temperature. That is what they mentioned very clearly. Azeotropes mixtures, that is a mixture of liquids having the same composition in liquid and vapor phase and boil at constant temperature. Yes, what are the types of Azeotropes mixture? Here, minimum boiling point Azeotropes and maximum boiling point Azeotropes. Okay, minimum boiling point, maximum boiling point. From where do we get this? See, generally ideal solution, non-ideal solution. From Raoult's law, we have gone to that. Okay, now which is does not obey the Raoult's law, that is non-ideal solution. From that only we got positive deviation and negative deviation, we got it. Okay, now positive deviation, negative, from that only Azeotropes mixtures are created. Yes, let us go and understand that minimum boiling point Azeotropes, a solution which show large positive deviation from Raoult's law, that is from minimum boiling point Azeotropes at a specific concentration. So that same concentration it should be. See, now example, ethanol and water. Both are having 95 percentage of ethanol by volume. Show minimum boiling point Azeotropes. What about maximum boiling point Azeotropes? Here, the solution which show large negative deviation from Raoult's law. Example, here water and HCl. Here 20.2 percentage by mass show a maximum boiling point Azeotropes. Here what they mentioned very clearly, the solution which show large negative deviation from Raoult's law from maximum boiling point Azeotropes at a particular composition. Please note down here particular composition comes means here by mass we are mentioning, whereas here specific concentration, because concentration that leads to what it is molarity. See here, that means here they mentioned by volume. Here composition, that means here they mentioned very clearly by mass. So molarity also here they mentioned very clearly indirectly. Hope you got a better idea about Azeotropes mixture. Come on, let us go and analyze some other questions related to the board. The next important questions from colligative property. You know, where do we get this colligative properties idea? That is Raoult's law, second category, non-volatile solute and volatile solvent. Okay, that non-volatile solute and volatile solvents which exhibit certain characteristic properties, that is depends only on the number of solute particles, not on the nature of solute particles. See, they are mentioning only the solute particles. How many number of solute particles are taking part, not on the nature of solute particles. Now, for example, suppose you are a tall or short, that is not at all a matter, don't get complex, but how much marks you are gaining, how much you are achieving your goal, that is matter. The same idea you just bring it, number of particles, that is a matter, not on the nature of particles, that is nature of solute particles. Yes, what are the four important properties of colligative properties? Number one, relative lowering vapor pressure. This is already we have gone through in our last previous video. The second one, elevation of boiling point, depression of freezing point, and osmotic pressure. These are all important points to be noted for the board exam, and important questions can be asked. Some also related questions are available. Yes, let us go and analyze each and everything very clearly. Now we are going to see the relative lowering vapor pressure related sum. It's very simple and easy one. Let us go and analyze. The vapor pressure of pure benzene at certain temperature is 0.850 bar, and non-volatile solid weighing 0.50 gram is dissolved in 39.0 gram of benzene. Molar mass, it is 78 gram per mole. Vapor pressure of a solution is found to be 0.845 bar. What is the molar mass of the solid? They asked very clearly, direct question, a non-volatile solid weighing 0.50 gram, which is dissolved in benzene. They are asking the question, what is the molar mass of that non-volatile solid? Right? Come on, let us go. What is the formula do we use here? We should use that formula. P naught A minus P divided by P naught A equal to WB by MB into MA by WA. Yes. Now let us go and analyze each and every points, what it has mentioned, what is the value. Let us apply for it. Now P naught A, what do you mean by P naught A? P naught A, it's a vapor pressure of a pure component. Okay, so vapor pressure of pure component. What is that vapor pressure of a pure component? It's a benzene. C6H6. Right? So how much it is? Actually 0.850 bar. Now, the next one, P. What is it, P? Vapor pressure of the solution. Vapor pressure of the solution. That is what you have learnt in Raoult's law, right? Okay. See, here how much? 0.845 bar. Right? Okay. Now, WB by MB into MA by WA. See, WB, it is AA and BB. All these are all. A, it is a solvent, and B, it is a solute. This already you have learnt very clearly. Okay, now WB, it is a non-volatile solid given mass, and molecular mass, that you have to find out what is the molar mass of the given solid. So this only you have to find out. The same way here, solvent, what is the solvent? Acts over here, benzene. So molecular mass of benzene and the given mass, how much it has taken for the dissolving. Here, this point you have to apply. Yes. Now let us go and identify WB. How much gram we have taken? 0.50 gram. Then MB, molecular mass of the given solid. It is a question mark. Yes. MA, what is it? Molecular mass of the solvent. Solvent, it is a benzene, right? So molecular mass of benzene, it is 78. Already they have given 78 gram per mole. Then WA, what it is, how much it has taken for dissolving. Here 39.0 gram they have taken. Okay, now let us apply the value. P naught A, how much? 0.850 minus, and P, what is the value? 0.845 divided by 0.850 equal to, here what it is, WB 0.50 divided by MB into, here MA, what it is, 78 gram per mole divided by 39.0 0.0. Okay, now we applied this value over here. Now we have to bring it outside. So MB. So from this, you know very well how to identify that. Here 0.005 divided by 0.85 equal to the same 0.50 into 78 divided by MB into 39. Now here we just bring it MB equal to, okay, now 0.50, right, into 78 into this will go up 0.85 divided by here 0.005 into 39. Now what is the value we are getting? Just go and identify. By the time you just pause that video and calculate that answer. Here the answer it is 170 gram per mole. You know why I put it that gram per mole? This is a solid molar mass of the solid. Molar mass of the solid equal to 170 gram per mole. Unit, it's very important. Hope you understand this question and it is very simple. Okay, let us go and analyze one more same kind of question. Here, calculate the mass of non-volatile solute. Molar mass, it is 40 gram per mole, which should be dissolved in 114 gram of octane to reduce vapor pressure 80 percentage. So this is actually same, something different. Come on, let us go and analyze which is different. The first one here, P naught A minus P divided by P naught A equal to WB by MB into MA by WA. Yes. Now, here in this point, what it is P naught A? P naught A, vapor pressure of the component A, right? So, vapor pressure of the component here, P naught A and P value you should know. So, here what it is P naught A, 80 percentage means here vapor pressure of the component, that means 100, and the vapor pressure of the solution, it is 80, right? Now, WB, WB, B it is a solute, A it is a solvent, right? Okay, now here calculate the mass of non-volatile solute. That is only the question, so you have to find out that only, right? MB, molar mass, they have given that molar mass, it is 40 gram per mole, which should be dissolved in 114 gram of octane. So 114 gram, so molar mass of solvent and WB, given mass of the solvent. So molar mass of the solvent, octane, right? Octane, C8H18. Calculate the molar mass of that solvent. Here they have given how much? Here 114 gram of octane. Octane. Okay, now molar mass of that octane, here what it is? 12, carbon 12 into 8 plus 1 into 18. Altogether it is 114 gram per mole. See, molar mass means you have to put that unit. That's very important. Now you have to find out that given mass of the solute. Yes. Now let us go and apply P naught A. How much? It is 100 minus 80 divided by 100 equal to WB by MB. How much? It is 40 into 114 divided by 114. Both are same only. So this is 20, right? So here 20 means here 100. here this and this will be cancelled. So 20 divided by 100 equal to WB by 40. Right? So here 1, here 5. Right? So 1 by 5 equal to WB by 40. So that means here WB we can bring it this side. So 40 divided by 5, here 8 gram. 5 it's are 40, right? So here what it is? 8 gram. So what is the mass of the given non-volatile solute? It is 8 gram is the answer. So mass of non-volatile. Calculate the mass of non-volatile solute. Mass of non-volatile solute. How much? 8 gram. Is it 8 gram or 8 gram per mole? It's 8 gram only because they asked to calculate the mass of non-volatile solute. Molar mass they did not mention. They asked mass of that given solute and molar mass already they have given. Hope you understand this kind of sums. Now, next point we are going to see that elevation of boiling point, depression of freezing point. These are the two main important points are there for the board topic, and osmotic pressure, reverse osmosis and application questions are there available in this point for upcoming videos.